Welcome back everyone to Wes Explains Best. Today we're going to be doing another Kuta software worksheet tutorial on the volume of pyramids and cones. One of the things you need to understand is the volume of pyramids and cones is very similar to that of prisms. So if you remember prisms, their volume was the area of the base times the height. I find this super interesting, but the volume of pyramids and cones, both of these, so how can I put that? Pyramids and cones is the area of the base times the height, just like it is with prisms, with the only exception is it's divided by 3. Or if you like, it's 1/3 times the area of the base times the height. That's the only difference. So here's your formulas that you're going to be using. There's a great demonstration video on YouTube. I'm going to try to link this in the description below on showing how that relates if you have a pyramid and you fill it up with water, which is volume. Volume is three-dimensional space, and you pour it into a prism of its similar size. So if we had something like this, obviously a prism has two bases, it would fill up only 1/3 of the way with the liquid. So that's pretty interesting that it's 1/3 the size. Now obviously for a cone, the volume of a cone, the area of the base is going to be pi r squared. So we multiply that by the height and divide by 3. For pyramids, we'll need to figure out the area of the base and then proceed from there. So let's go ahead and start with our first one, number 1. We have a cone here, and so we just need to plug in our radius, which is 2 squared times pi, and then our height is the distance to the vertex. So here's our vertex. Again, here's a vertex for this pyramid. It's the top point, and the distance between is the height. So that's our height. So we multiply that by 7, and we're going to divide that by 3. So we have 4 pi times 7 divided by 3. That's 28 pi divided by 3. It wants us to round these answers. I would, as a geometry teacher, I would accept 28 divided by 3 pi. We're going to go ahead and multiply this for this particular worksheet. I do that on my calculator, and I get rounded 29.3. 29.3. What are my units? Miles cubed. That is one big cone right there. All right, moving on to the next one. Let's go ahead and let's move on to number 2. We have a triangular pyramid here. We need to be very careful. Here's our volume. It's the area of the base times the height divided by 3. So the first thing we should identify is what is our base. Our base is, that is fat. Our base is this triangle here. Very important that you identify the base. So now we are going to first find the area of the base. Area of the base is going to be, since it's a triangle and it's perpendicular between these two legs, we can do 1/2 the base times the height. 1/2 times our base is 3. We can call our height 4. It doesn't really matter since they're perpendicular to each other. That's 12 divided by 2 is 6. So we have the area of the base now, and now we just need to multiply it by the height, which is the distance to the vertex, and that is 4. So our volume, let's change color again. Our volume is going to be equal to our area of the base, which is, what did I say, 6, times our height, which is 4, and we're going to divide that by 3. So we get 24 divided by 3. We get 8 miles cubed. Well, miles, there we go. So that is going to be our volume for number 2. Let's see if we can find a tougher one. Okay, we have, well, for these ones, these are rectangular pyramids. These are going to be pretty easy because we just have the area of a rectangle. As you remember, area of a rectangle is equal to length times width. And then we multiply that by the height and then divide by 3. Here we have a little bit tougher problems because we have a regular polygon. So we need to find the area of a regular polygon. And that is equal to 1/2 the perimeter of the base times the apothem. The apothem is this distance, let me make it a little bit smaller. This distance right here, perpendicular from the midpoint of a side to the center. So let's go ahead and do this problem. First, let's find our perimeter of the base. Since we have, this side is 6 and there's 6 sides, we can do 6 times 6, so we get 36 for our perimeter. 1/2 times our perimeter, 36, times the apothem, which is 5.2. So we have 36 times 5.2 divided by 2, or times 1/2. I got 93.6 meters cubed. So it's really not that bad. All you need to make sure is you find the right measurements. For this one, make sure you use the radius and not the diameter for number 8. Other than that, this should be pretty straightforward. It's just a matter of calculating and using these formulas. Hope you found this helpful, and I'll see you next time on Wes Explains Best. Take care.